This next lesson is on loops. Loops have three main parts to them. First, they're going to be able to loop a certain number of times, and in order to determine the number of times, you need a starting condition, a condition to see if it's going to go again, and something which changes the condition for it to go from being a true statement to a false statement eventually. Here is an example. Int num. I'm going to start num with a 0 in it. The while loop is our first loop we're going to see. There are three different loop styles that you can use: the while, the do while, and the for loop. The while has the while command, which turns blue, and a condition statement. So it is extremely similar to an if statement. If you change the word while to an if, you make it into an if statement. So here's the condition. The condition, if it is true, it will do what's inside these parentheses here, the brackets. If it's false, it's going to exit or not do it. So I'm going to say while num is less than 10. Since 0 is less than 10, it will go ahead and go in here, and I'm going to go ahead and say true. It's going to do this output of true, and then it's going to go back and check the condition. If the condition is still true, it will do it again. If it's false, it'll stop. Since I never changed the value of num inside the loop, notice what happens. It infinitely will be doing true. Look at this little thing going down. Okay, so that makes us an infinite loop. If we want the infinite loop to stop, the value of num must be increased in order for it to eventually be bigger than 10 or equal to. In this case, it wrote true 10 times. So from 0, the first time it ran, all the way to 9. From 0 to 9 is 10 times. I'm going to go ahead and instead of outputting true, I am going to output the value of num so that we could see it in action as it's increasing. In the beginning, num equals 0, num equals 1, num equals 2. So it's going to keep going through this loop until num equals 9. It increases by 1. 10 is not less than 10. It's false. It'll exit. Okay? So the three parts of a loop would be where you initialize the loop counter. The condition I was going to say repeat, but to loop. The condition is, as long as it's less than 10, keep doing it. And this will modify the counter. Now, if I modify the counter to where it does num equals num plus 2, now it's increasing by 2 each time, notice it did not go 10 times, it only went 5. The first time when it was 0, and then 2, 4, 6, 8. When you add 2 to 8, that makes 10, which makes it false, and it'll stop there. So you can modify the counter here. Let me close these windows. You can modify those counters, or if I leave it as +1, I can modify the starting location. If I want to start from 5, it will go from 5 all the way to 9. So you could change the initialization where it starts from. You could finish the condition up to where it's going to go. So if I change this to 15, it'll go from 5 to 14 because I didn't have less than or equal to. So I could change this value as well. So you could control how your loop will function based on those three statements there. So the loop is not really that difficult, including the ability to do the following. Let's say I want to start at 10 and I want this to keep going as long as num is greater than 0. If I have 10 as the start and I want to go as long as it's greater than 0, eventually it needs to be lower than 0 for it to stop. So my counter is probably going to count down. I press play, it starts at 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0 is not greater than 0, therefore it will exit. Okay, so you could control the loop however you would like, including the following. Cout please enter a value for num. In this case, num is being modified not by a counter which is increasing or decreasing, but by the user, which is going to manually enter a number. Let's say 8. Please enter a number. 9, 42, 22, 1, -5. Since -5 makes this statement false, okay, so -5 is not greater than 0, it'll stop. So this is user controlled loop. You can do a program which will say press 1 to buy something, press 2 to sell something, press 3 to exit. So you might be doing a loop which they press 1, they bought something, and you give them the options again, and they buy something again, they start selling something, and it won't exit until they press 3, in which case, while the num does not equal to 3 would give you a loop, an infinite loop, as long as they haven't entered option 3 to exit. The next loop, I'm going to comment this out, exit this. I'm going to create a num equals 0, and instead of doing a while loop, I will do a do while. Now, this is the only one that does require a semicolon at the end, and the reason why is because we usually assume that a command will have these brackets as its only statement, whereas the do not only has the brackets, but it has something else attached to it at the end, and since there are no brackets to end it, it needs to be ended with the semicolon. So it's going to do the following: cout num equals num, and then I want to increase num equals num plus 1. Since we're in this topic, be aware that you can do the following to increase or decrease the value by 1. You can do this line. You can do num plus equals 1, which is doing the exact same thing as this is, but you do not have to write the num again. So some people create very long variable names and don't want to write the name again, so they simply do a plus equals. They put the plus on the left side of the equals to represent the same information. Or what most people are used to nowadays is num plus plus. Num plus plus will increase by 1, whereas if you do num minus minus, it will decrease by 1. This plus plus and minus minus only works when you're modifying the value by 1. If you're not modifying the value by 1, this is not possible, and you would have to do it either this way or this way with the number desired, such as if you're increasing by 5s. Okay, so I'm going to go ahead and change it back to 1. Keep the traditional long style format. Now I'm going to run it, see what goes on. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. To me, it looks like it's doing the exact same thing as a while loop. In reality, there's only one difference between them. Here, it will do this command first, and then it'll check the condition whether it should do it again. This while loop will first check the condition if it should do it, and then after the condition, it'll go back and check if it does it again. So if on the first one, up here, I'm going to uncomment this so we can see it better. If in this one I place the value num equals to 0, the same as this one, and the num is less than 10, and I am going to copy this so that the content is exactly the same. Okay, both of these are going to do the exact same thing. I'm going to do 2 endls so we can separate both of them. And what is the problem? Oh, creating num twice, is that it? Where is it? The redefined, yes. Let's not redefine it twice. So I have int num and then int num. It does not want you to define the name twice. So I'm going to reinitialize num. So in this, I created num, I used num, and now here I just reinitialized it back to 0 so that I could use it with this bottom one. Alright, so the first one goes from 0 to 9, and then I reinitialized it back to 0, 0 to 9. They're doing the exact same thing. Notice that if I change num equals to 20, I set it back to 20 for this one as well. Let's see what goes on. For the first one, it did not run because when it first went in, it said, nope, it is not less than 10. So it skips it. Whereas this one down here, it did it once when num equals 20. It increased it by 1. 21 is not less than 10, so it stops. It only went one time. So that is the difference between both of them. This one checks before it does it. This one checks after it does it, guaranteeing that it does it at least once. A good use for this one would be if you're playing a video game. You start off the video game as you're playing the game, and at the end, you decide whether you're going to play again. Okay. I'll go ahead and comment out both of these and show you the last of the loops and my personal favorite. Okay, so in this case, when I run it, it will output num equals 0 all the way to num equals 9. So it's doing the exact same things as the other two were when it started back at 0. Let me just go ahead and change that so that we know. So they're doing the exact same thing. This one, though, has all three together in the for loop statement. It has this part, which is the initialization, followed by a semicolon. It has the condition, followed by a semicolon. And it has our increment, which is inside without a semicolon for this one. So it's separated only by 2 semicolons. Okay. You can basically, if you remember what this means, that means you're increasing num by 2. You can do the same thing as before to where it goes by 2s, 0, 2, 4, 6, 8, and so forth. you could change where it starts from. So if I started from 5 and it's going every 2, it's going to output 5, 7, and 9. Okay, so it's going by 2s, starting with 5. The way it evaluates this initialization here happens in the beginning of the for loop. Then it checks the condition. So it works exactly as our while loop, not the do while. It'll check it. If it's true, it'll do the command, increase, and then check it again to see if it should do it one more time. Okay. Be aware that this portion here, as well as any other portion, does not have to have content in it. It is possible for you to move this content out So I initialized num equals to 5 outside of the loop. Notice there is nothing here, so it's blank, and it should still function the same way. So this first area is just reserving space for whenever you want to initialize. In the same way, this last part here, you could have simply placed it down here, add a semicolon, those are important, and it's doing much the same thing. So you do not have to write it the way it is here for the for loop. If you want to write it this way, you do need these two. But if you were to write it this way, I would ask you as a student why exactly you decided to use a for loop. Why didn't you just put while and remove these two things? As you can see, it would be written the same way, so there was no use for a for. I personally use a for loop because I enjoy having all of this data placed on the same line. So the start, the condition, and the increment all visible together. If you have a whole bunch of code in between the while loop, so down here you start separating a whole bunch of code, you would have to see where you start, the condition, and then scroll all the way down to see what you're increasing it by. So you don't have it right next to each other, making it a little harder to read. Another nice thing about the for loop, we are defining, this is probably what makes the for loop superior to the while loop, we are defining num equals 5 inside the condition. Therefore, if I try to see out num outside the condition, notice that it says num is undefined. You might say, well, I defined it here, in which case it is true. But when you define it inside a for loop, it only exists inside the for loop. Once this is done, everything defined inside is gone. Therefore, num no longer exists. I would have to define num once again. Here's another thing you should know. If, for some reason, I am doing this one here, okay, well, let's just remove all this space. Let's do this. Remove that. Okay. So we define int num. Notice num now exists. When I click on num, it selects it in blue. Did it select this in blue? No. It did not select this one either. So this num is not the same as this num. This one is the same as this other num. This num was created inside the main, which means everything in the main is able to see this variable. This specific num is only referencing its local num. All of this is local to itself. Now, if I had not defined a local variable called num, such as if I call this num2, then this num is now talking about the outer num. Okay? So once I change this to num, any reference to num is now talking about itself, because now there exists a local variable with that name, so it's only going to use the local one. If there was no local, it's going to look for the global, in which case this is global to everything inside of it, including the for loop. Might get a little confusing, but the reason why I like this is because if I were to write another for loop, I could use our variable num again and define a new num. Num equals, okay, let's say 7, num is less than 10, num plus. So in this case, I use another variable num, and I know that once this is done outside here, it cleaned up the mess for me. It no longer needs to remember this variable, since most uses of that variable is as a counter. I do see a lot of students calling it, instead of num, they call it count. Whenever we're using arrays later on, they say int index. I personally, in all of the notes that I'm going to give you, will almost always call this x. So for int x equals 5, x is less than 10, x plus plus, this is how I would usually write it. So be aware that when you see the letter x, I'm probably talking about a loop. Now, if I were to use another loop inside of this loop, which is possible, I would call it y. Some people might call it outer and inner loop. I prefer x, y, and then z, and then if you're doing another loop inside of it, which I don't see why you would in this class, you could call it any other letter or any name that you prefer. In this case, notice that, let's go ahead and change this to 0. Okay, and let's make this going up by 1. Notice that this loop starts from 0, not 3 pluses, starts from 0 all the way to less than 10, increasing by 1 each time, which means it's going to go 10 times. Now, each time that it does this once, it's going to go in here and it's going to do this loop. So it's going to do this loop 10 times. This loop itself is running from 0 to less than 10, which means this one's also going 10 times. But since this 10 times is being run inside of this one, which runs 10 times, it will run a total times of 100, which is 10 times 10. Okay, so be aware that the inner loop goes more times than the outer loop, especially if you, for any reason that you might need another for loop. This one here, it runs 10 times, but it runs 1,000 times because it runs 10 times for each one of these times, and since this one runs 100 times, it's basically 100 times 10, 1,000. Okay, so you might not see too many programs which have embedded for loops, but be aware the use of them, not too difficult as long as you have them nice and organized, and it has indentation which automatically happens. So this is automatically indented here. This for loop will do everything inside the indentation that is this far. So it does all of this content 10 times, whereas this loop does all of this content 10 times. So the indentation lets you know where you're currently at. I do believe that concludes the beginning introduction to loops. Thank you.